Hello all and welcome to this video in which we shall discuss analyzing the first derivative algebraically, more specifically finding the relative maximum or minimum of a function. So let's draw a random graph of any function and let's discuss what's going on. So here we have something called a minimum. Here we have something called a maximum. Here we have something called a minimum as well. And if we analyze the way the graph is moving, we can see that this here is decreasing and this is decreasing, right? So this is decreasing, decreasing, and here it's increasing, and here it's increasing as well. So there are certain inferences which we can make from the shape of the curve. If the function is decreasing, this means it has a negative slope. We said that y dash has to do with the slope. So y dash is negative. And here as well, y dash is negative. If the function is increasing, then y dash is positive, of course. And in the turning points, so the blue points, minimum and maximum, are called turning points. We have zero slope. So the y dash is zero, because if you draw a tangent, it's going to be horizontal, and horizontal lines have zero slope. So y dash is zero, and y dash here as well is zero. So this is important to understand with regards to how the shape of the curve can give us information about the slope or the value of y dash. Now, for this question, we are required to find the x-coordinates of the relative maxima of fx. So f of x can be used to obtain y dash or f dash. Of course, they mean the exact same thing. So f dash here will be negative 3x squared minus 12x plus 36. And we want to get the x-coordinates of the relative maxima. So we want to get where f dash is equal to 0. So we're going to equate this to 0. Now we can factorize, but first let's take negative 3 out as a common factor. Of course, you can use mode 5, 3, but it's better to factorize. So negative 3 times x squared plus 4x minus 12 equals 0. And then we factorize this. So negative 3 times x plus 6 times x minus 2 equals 0. Now, this format here gives us the two critical points or values of x where y dash will equal 0. So x is negative 6 and x is 2. We create a table of x and y dash. We leave the first column empty, and then we put negative 6, and then leave another empty box, and then put 2, and then leave a third empty box. Now, we know that the value of y dash is 0 here and here. We are going to try to substitute other values of x and figure out the sign of y dash. So remember, y dash is negative 3 times x plus 6 times x minus 2. Now, if we put, let's take any random values, any random numbers. Let's take negative 7, negative 5, and 3, for example. So this number has to be bigger than 2. This number has to be smaller than negative 6. And this number has to be somewhere in between them. So let's take negative 7, negative 5, and 2, and 3, excuse me. So For -7, we have -3 times -7 plus 6 is -1. -7 minus 2 is -9. So this gives us -27. For -5, we have -3 times -5 plus 6 is 1. -5 minus 2, -7. So this is 21. For the 3, we have -3 times 3 plus 6, which is 9, times 3 minus 2, which is 1. And this is -27 as well. So we don't really care about the numbers that we obtained, we just care about their sign. So negative, positive, negative. I'm going to put here negative, positive, negative. We said that when y dash is negative, the function is decreasing. So we can draw something like a decreasing line here, like this. For y dash is positive, it's increasing. For y dash is negative, it's decreasing. So we can see that we have a minimum here. So this is a minimum. And we have a maximum here. Now this question is asking about maxima. So the answer to that will be 2. Let's try another problem. So again, we begin by getting f dash or y dash, which is -8 x power 3 minus 24 x power 2. And this is equal to 0. So let's take -8 as a common factor, and let's take x power 2 as well. So we are left with x plus 3 equals to 0. So the solutions are x equals 0 and x equals -3. Now we're going to draw the table. X versus y dash. Leave an empty box, write -3, leave an empty box, write 0, leave an empty box. These are 0 here. And we want to get the sign of f dash between them. So we just take any other numbers. We can take -4, -2, and 1, for example. We rewrite the equation, which is -8 x power 2 times x plus 3. And we start plugging the 3 values we chose. So -4, -2, and 1. So -4, I get -8 times -4 power 2, which is 16, times -4 plus 3, which is -1. Like we said, we don't really care what the number is, we just care about whether it's positive or negative. So this here is positive. Here we have -8 times -2 power 2, which is 4, times -2 plus 3, which is 1. So the end result is negative. And for the 1, we have -8 times 1 times 4, which is also negative. All right. So here we have positive, negative, and negative. If we draw the graph, we get something increasing and then decreasing and then decreasing again. So when you have decreasing followed by decreasing, this is not a maximum or a minimum. This is something weird or something that is beyond the level of this particular exercise. It's called an inflection point, but that's not our purpose right now. We can obviously see here that this point here is a maximum. The 0 here is a maximum because it's at the top, and they want the coordinate of the relative maxima. So the value is -3. Let's try a third problem. Again, the first step is to differentiate. So 5 times 2 over 5 is 2. So 2x power 4 minus 16x power 3 plus 30x power 2. This is y dash. And we said that this is going to equal 0. Now we can take 2x power 2 as a common factor. We will be left with x power 2 minus 8x plus 15 equals 0. So 2x power 2 times x minus 5, x minus 3 equals to 0. So the values of interest are 3 and 5. We're going to create our table, x versus y dash, put 3, put 5, and make sure to have gaps between them. And the y dash is 0 here and here. Oh, excuse me, I'm sorry. We also have 0. So the values here of interest are 0, 5, and 3. So we actually have 3 values of interest here. So no worries, we'll just make a bigger table. So let me just adjust. Put here 0 as well. And y dash is 0 here as well. Again, we want to find values. First, a value that is smaller than 0, so -1. And then something between 0 and 3, which is 1. Something between 3 and 5, so 4, and maybe 6. And we're going to plug these values into the equation. So let me just find some space to do that. So we have 2x power 2 times x minus 5 times x minus 3. And we have -1, 1, 4, 6. We want to just get the sign of y dash in each of these. So here we have 2 times -1 power 2, which is 1. -1 minus 5 is -6. -1 minus 3 is -4. So this will be positive. Here we have 2 times 1 times 1 minus 5, which is -4. 1 minus 3, -2. So again, positive. 2 times 4 power 2, 16. 4 minus 5, -1. 4 minus 3, 1. So this here is negative. 2 times 36. 6 minus 5 is +1. 6 minus 3 is +3. So this is positive. So we have positive, positive, negative, positive. Positive, positive, negative, positive. This tells us that the function here is increasing. And here it's increasing further. So this is an inflection point, but never mind for now. Here it's decreasing. And finally here it's increasing. So this is a maximum. And this is a minimum. So they want the relative minima. So all we have to do is just write 5. And that's it. So this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.